Okay, with question 43, where it says sketch the graph of y equals sec phi for values of x satisfying quite a big range there. Okay, you just got to think about what sec phi is in relation to in terms of a trig function. Well, we know sec phi, okay, is 1 over cos, isn't it? That's what sec is, 1 over cos phi. So you can see here, right, why I've drawn a quick sketch here of the cos graph, okay? Because you can use the cos graph to get an understanding of the sec graph, right? Simple as that. So in order to draw the sec graph, ideally you need to have a drawing or a sketch of the cos graph, and we can work from there, okay? Important points then on the cos graph, right, is when the cos is equal to 0. So here, okay, here, and here, when it's equal to 0, because you have issues, don't you? When cos is 0, you have 1 divided by 0, okay, which you can't do, can you? When you do that on your calculator, this is math error, right? So actually there, we can have asymptotes, okay? So I'm going to start to draw my sec graph on the cos graph here, just to sort of, you will see how it connects, right? So we can have asymptotes where the cos graph is 0, okay? And just the reason that, again, the reason why is because when cos is 0 here, 1 over cos 0 is infinity, so sec then will be infinity. So we can have asymptotes whenever the graph is 0, okay? Okay, so we'll have asymptotes on the sec graph, cosec graph, and the cot graph, right? That's how it sort of works, because whenever it's equal to 0, 1 over 0 is infinity. So you just got to see what happens then in between these asymptotes. That's what's important here. Now what I'll do, right, just to keep it simple, I'll just focus on this particular area here to start with. I might not do it all, but I'll just focus on this bit here. And if you think about it, let's go in the middle here when it's 1, right? So in this case here, this is when cos is 1, yeah? When cos is 1. So when cos is 1, then you will have 1 over 1, yeah? So cos is 1, you'll have 1 over 1, which is also 1. So sec will also be 1 as well. So your points are the same there for the sec graph, right? They'd be identical. But then as we saw earlier, right, when it's 90 here, when we've got cos 90 is 0, okay? So 1 over 0 is infinity. So this is going to shoot to infinity. So we've got to see what sort of happens. The other thing to think about then is as it gets close to 90, right, as it gets close to 90, cos gets really small, doesn't it? Cos gets really small, positive small, as it gets close to 90. So if the bottom number here gets really, really small, 1 divided by a really small is a big number. So what happens is this shoots to infinity, okay? So you kind of get like a U shape here, right? Like that, it shoots along the asymptote, okay? It doesn't actually get to it, okay? But it shoots along. And the same sort of thing goes on here. Cos gets really small here as we get to minus 90, while this gets really small here. So this will shoot off. 1 divided by small is infinity, so it'll shoot off. So you get like a U-shaped, okay? Along the asymptote there, it just keeps on going, right? So that's part of the graph there. And then you've got your asymptote where it's sort of undefined. And you've got to then just reason then what actually goes on here. And there's very similar ideas, right? You have over here. For instance here, if we focus on this point here, minus 1, yeah? Now, in this case, cos is minus 1. So if you've got minus 1 here, 1 over minus 1, 1 divided by minus 1 is also minus 1. So you've got your point here, okay? So sec coincides with the cos. It's the same here. But let's see what happens then as we get here. Now, as the graph gets close to 0, as cos gets close to 0, cos gets really small, okay? Cos gets really small. So this bottom number is really small, but it's negative small, isn't it? It'd be like minus 0 point something, right? So a really small number here means this gets big, but because it's negative small, it'll get really big, but in terms of minus, right? So it'll go towards minus infinity, because you have 1 divided by a really small negative number, be negative infinity. So what happens is then you have this going on, okay, along the asymptote, and the same then goes here. You can use the same reasoning, okay, and that's what happens as you go along, right? That's exactly what happens as you go along. Okay, so you can do this bit here, okay, because it's 0 there, it shoots off to infinity, okay, so we just do this bit here, oops, slip a bit there, okay, so it goes along the asymptote, and we don't need to go further than 360, okay, and you could do the same here, right, that point will coincide, and because it's really small, negative small here, it goes to minus infinity, like this, okay, so you can keep going, and the same here, okay, like that. So So that's your graph. So if I got rid of now the purple graph here, the cos graph, you can see then what the sec graph looks like. Not difficult, right? It's not complicated. You just use those certain values, the important values, 90, 180, 270, 360. You look at what happens to cos, use that then with a 1 over it to get the idea of the graph, okay? Now I've got an outstanding piece of work here where it's also been drawn here, the sec graph. But you can see as well then, we've just drawn that, we can see as well that the cosec graph would be, okay? So if they ask you the cosec, well, that'll be 1 over sine. And notice here the asymptotes have been drawn again, right? The asymptotes are drawn where sine is 0, okay? Sine is 0 here at 360, 180 is 0, the asymptote is the axis, minus 180, the asymptote there. And the same principle, you get exactly the same, right? It's just like being shifted along, that's all, exactly the same. Now the cot graph, right, looks even more sort of complicated, but again you have asymptotes, right? And you have asymptotes this time when tan is 0. So if you look at the tan graph here in blue, when tan is 0 there, that's an asymptote, okay? When tan is 0 there at 180, you've got an asymptote there. And you use the same reasoning, right? Exactly the same reasoning, okay? As tan gets really small, 1 over tan then, 1 over a really small number will go to infinity. So it's the same sort of idea, right?